question 11, we have a curve which is y is equals to 8 upon x plus 2 and the line 2y plus x equals to 8 intersecting at points A and B. The point C lies on the curve and the tangent to the curve at C is parallel to AB. So we know that if we make a tangent to the curve at C, it is parallel to AB, which means that the gradient of AB and the tangent to C are equal. We have to find the coordinates of A, B, and C. To find the coordinates of A and B, we can solve the equation of the curve, which is 8 upon x plus 2, and the equation of the line, which is y is equals to 8 minus x upon 2. We can solve them simultaneously. So cross multiplying, we'll get x plus 2 multiplied by 8 minus x is equals to 16. Expanding this, we get 16 minus x square plus 16. So this will be x into 8, which is 8x minus x square plus 16 minus 2x is equals to positive 16. 16 and 16 will cancel out. We will have 8x minus 2x, which is equal to 6x minus x square is equal to 0. Now there is one common mistake that students make. They take the 6x or the x square on the other side and cancel out the values of x, and they give x equals to 6. Now in this case, we know that we already have two values of x, so students can avoid this mistake, but if it is not mentioned, they only give one solution, which results in a loss of marks. To avoid this, we always take x common and we write 6 minus x equals to 0. So we have two values of x, which is x equals to 0 and x equals to positive 6. Substituting these values into the equation of the curve or the line, we can get the value of y. So substituting 0 in the equation of the curve, 8 upon 0 plus 2, we get y equals to 4. So these are the coordinates of A, as we know that the x coordinate of A would be 0 as it is on the y-axis. And substituting x equals to 6, not 16 obviously. So this is x equals to 6. Into the equation 8 upon 6 plus 2, we get y equals to 1. These are the coordinates of B. For coordinates of C, we know that the gradient at point C is equal to the gradient of AB. So the gradient of AB is equals to y2 minus y1. So we can write 1 minus 4 upon x2 minus x1. So we know that the gradient of AB is minus 3 upon 6 or minus 1 upon 2. The gradient of the curve at point C is dy dx. So finding dy dx, we know that the equation of the curve is 8x plus 2 to the power minus 1. Differentiating this, we get minus 8 into x plus 2 to the power minus 2, or minus 8 upon x plus 2 whole squared. Equating this to the gradient of the line AB, we have minus 8 upon x plus 2 whole squared is equals to negative 1 upon 2. The negative signs cancel out, and we have x plus 2 whole squared is equals to 16. Taking square root on both the sides, we have x plus 2 is equals to positive 4. We won't be taking negative 4 as we know that C has a positive x value. So x is equals to 4 minus 2, which is 2. Substituting x equals 2 into the equation of the curve, which is y is equals to 8 upon x plus 2. So we get y is equals to 8 upon 2 plus 2, which is y is equals to 2. So the coordinates of C are 2 and 2. In part B, we have to find the volume generated when the shaded region bounded by the curve is rotated through the x-axis. Now for the volume of the shaded region, we will find the volume under the line and subtract it from the volume under the curve, and this will give us the shaded region. Because the volume under the line would be this whole area, and the volume under the curve would be this part. So subtracting these two volumes, you will get the volume of the shaded region. So first, finding the volume of the line, volume under the line, we know that to find the volume, we take pi times square of the function, and we know that the limits are 6 and 0, as the coordinates of B, the x coordinate was 6, and this is the coordinate of A, which is 0. So the equation of the line is 8 minus x upon 2. So we write 8 minus x upon 2 whole squared dx, and taking the limits as 6 and 0. So we have 8 minus x whole squared upon 4. Integrating this, we get 8 minus x to the power 3 divided by 4. So we multiplied by the new power, which is 3, and the derivative of the function 8 minus x, which is minus 1. So we get 8 minus x whole cube upon minus 12. Now we have to substitute the limits, which are 6 and 0. So substituting 6 into the equation, we have 8 minus 6, which is 2 whole cube 8. So we have minus 8 upon 12. And substituting 0 into the equation, we have 8 cube, which is 512 upon minus 12. So we have minus 512 upon 12. So minus 8 plus 512 is 504 divided by 12. We have 42 pi, which is the volume under the line. Now for the volume under the curve, we know that the equation of the curve is 8 upon x plus 2. So 8 upon x plus 2, first we whole squared this, and then we integrate, taking the limits as 6 and 0 again. So this will become 64 into x plus 2 to the power minus 2. The limits are 6 and 0. Now integrating this, we get 64 into x plus 2 to the power minus 1 divided by minus 1. So we have minus 64 upon x plus 2. Now substituting the upper limit, which is 6, we get minus 64 upon 6 plus 2, which is 8. And then substituting 0, we get minus 64 upon 0 plus 2, which is 2. So this will become minus 32. So this will become minus 8 plus 32, which is 24. And as pi was a constant, so this will become 24 pi. So for the volume of the shaded region, we will take the volume under the curve, which was 42 pi, minus the volume under the curve, which is 24 pi. So 42 pi minus 24 pi would become 18 pi, which is the volume of the shaded region.